Terraforming Mars, the idea of turning the red planet into a second Earth, has captivated scientists and science fiction fans for decades. But just how far-fetched is this idea? What parts are based in science and what are still up in the air? That's what we'll explore in today's episode. So, first, let's lay out the basics of terraforming. Making Mars habitable like Earth would mean more than just building a few dome-shaped shelters. It's about fundamentally changing its environment on a large scale. That includes its atmosphere, temperature, surface water, and soil chemistry. And it's a massive undertaking. Mars is a very different place from Earth. Its gravity is only about 38% of Earth's gravity, which affects how well an atmosphere is retained and how humans adapt. Its atmosphere is 100 times thinner than Earth's, mostly made of carbon dioxide and lacking vital components like oxygen and water vapor. The average surface temperature is around -80 degrees Fahrenheit, and Mars doesn't have a global magnetic field to shield it from solar radiation, which is deadly to life as we know it. Despite these differences, Mars does have some things going for it. It gets about 43% as much sunlight per year as Earth, so it's not completely dark. It has polar ice caps made of water and a layer of frozen carbon dioxide. And there's evidence of liquid water having flowed on its surface in the past. So it's not starting from absolute zero. With all that in mind, terraforming aims to turn Mars into a Goldilocks planet similar to Earth, where liquid water can exist stably on the surface. It's not necessarily about replicating Earth exactly, but about creating an environment where life as we know it can thrive. But why bother with terraforming at all? Why not just leave Mars alone? There are several reasons. First, the romantic idea of humans becoming a multiplanetary species. Science fiction has long imagined Mars as a new home, beyond our crowded and sometimes troubled Earth. Terraforming would make that transition more like a second Earth rather than a distant colony. Second, Mars has potential resources worth exploiting, including water, minerals, and maybe even subsurface fuel deposits. If humans can survive there, it opens up opportunities for exploration, scientific research, manufacturing, and potentially new sources of income. Third, terraforming might not be as far-fetched as it seems. Many scientists believe it's theoretically possible with enough engineering effort. While it won't happen anytime soon, the goalposts keep moving forward. What was once considered impossible becomes possible, then merely very hard. Now let's delve into the actual science of terraforming Mars. What steps are involved and what are their chances of success? Terraforming will require major changes to Mars' atmosphere, temperature, surface water, and magnetic field. All these factors are linked. Changing one will affect the others. Here's a breakdown of the biggest challenges. Atmosphere. Mars' atmosphere is too thin and cold to support liquid water or allow humans to breathe. Its pressure is only 0.9 kilopascals versus Earth's 101 kilopascals. And it's mostly carbon dioxide, which we can't breathe. Warming Mars up is crucial, because the whole planet must be warmer for water to exist in liquid form. A thicker atmosphere traps more heat via the greenhouse effect. To thicken the atmosphere, scientists propose releasing greenhouse gases from Mars' surface or other sources. Options include mining and releasing carbon dioxide, methane, or nitrogen compounds trapped in soil and ice caps, which are present on Mars. Another idea is using powerful synthetic greenhouse gases. Though this requires figuring out what to use and how to deliver it. Alternatively, mirrors in space could focus sunlight onto Mars, warming it and gradually increasing atmospheric pressure. But Mars' gravity is too low to hold on to a thick atmosphere forever. Any atmosphere we create could gradually leak away over millions of years, unless measures are taken to retain it. For example, magnetic field manipulation or atmospheric anchors could help. Water. Mars has water in its soil and ice caps, but it must be warmed up to release it. Liquid water is crucial for life and creates a more hospitable atmosphere. To achieve this, scientists propose heating Mars up, using lasers, nuclear bombs, or mirrors. Once liquid water exists, maintaining it will require managing the atmosphere, radiation, and temperature. Radiation. Mars lacks a global magnetic field, exposing its surface to deadly cosmic and solar radiation. To protect life, scientists suggest creating artificial magnetic fields using magnetic mirrors or other methods. The challenge is figuring out how to generate and shape the magnetic field. Now, let's talk about timelines and costs. How long would terraforming take, and how much would it cost? There's no single answer since terraforming efforts could vary drastically in scale and scope. But let's consider some estimates. To double Mars' atmospheric pressure to about 20 kilopascals, it could take centuries or longer, depending on the method. This is necessary to create liquid water and sustain life. Doubling the atmospheric pressure would also warm Mars up somewhat, but additional measures would be needed to reach Earth-like temperatures. Maintaining these conditions over millions of years would require ongoing resource investment. Regarding cost, terraforming is practically immeasurable due to the scale and complexity. Some rough estimates suggest it could easily cost tens of trillions of dollars or more, assuming that resources can be efficiently extracted and used. But there are unknown unknowns. New discoveries and technologies could dramatically change the cost and feasibility. Now, let's discuss the challenges and risks associated with terraforming Mars. Could it harm any native Martian life? Should humans have the right to change an entire planet? There's no easy answer to these complex questions. Concerning native life, we currently have no proof of any life on Mars. But scientists believe it may have existed in the past and could exist in the present. Microbes, if they exist, could be radically different from life on Earth, making discovery challenging. Changing Mars' environment could wipe out any extant life, whether we find it or not. Regarding the right to terraform, there are valid arguments on both sides. On one hand, humans have explored and altered parts of Earth for thousands of years. We've domesticated plants and animals, modified ecosystems, and reshaped landscapes. Terraforming could be seen as an extension of that drive to adapt our surroundings. On the other hand, Mars is a separate planet with its own unique history and potential for life. Some argue we shouldn't alter it fundamentally without clear justification. There's also the question of who decides. Should international organizations, governments, corporations, or individuals have the power to change Mars? In summary, terraforming Mars is a fascinating concept that pushes the boundaries of science, technology, and philosophy. It's a topic that inspires science, engineering, and the imagination, encouraging us to explore the solar system and what it means to be human. In a universe full of wonders, Mars holds a special place in our collective consciousness. And as we continue to explore and understand our place in the cosmos, the dream of terraforming Mars serves as a reminder of humanity's boundless curiosity and spirit of adventure. Thanks for watching. If you enjoyed this video, be sure to subscribe and check out our other videos. We love exploring all the weird, wild, and wonderful corners of the universe and hope you enjoy learning alongside us. Thanks for watching.